So hi everyone, welcome to my YouTube channel MNIT and Explain. So if you are new to my channel, then please subscribe to my channel. Also you can share with your friends. So today we will solve another problem, right? The problem is also from the same Leetcode list, like blind 75 Leetcode question. So today question is threesome. So it is the most important question which are asked in any interview. So actually this question will be also asked in my one of interview. So let's understood the problem first, and then after that we will jump to the solution part. So in this problem we have given a array, right? And we have to find the triplet, right? We have to find the triplet whose sum is 0. Like in this case, there is a triplet -1, -1 and 2, and whose sum is equal to 0. And also another triplet is -1, 0 and 0. And if you sum this three element, then it is equal to 0, right? So this is a basic question, and we have to find just a triplet, right? We return this triplet -1, 0 and 1, right? Also -1, -1 and 2. So let's move to the solution part and think how can we solve this problem. So actually there are two solutions, right? So this is the first solution. We can use three loops, right? We can use three loops, and but the important things is we can also take care of duplicate, right? Because maybe in this triplet we can't also duplicate, but in this question it is clearly say that our solution set must not contain any duplicates, right? So let's discuss the approach. So approach is the first step is sort the given array, right? And the second step is find out the triplet whose sum is equal to 0. So let's suppose this is a initial given array. This is this one, and after the sorting we will get -4, -1, -1, 0, 1 and 2, right? So after that, if we have three pointer, right? I, J, K. Okay. So what can I do? In this case, we can take three elements which are present at their respective index, like ith element, jth element, and kth element, right? And here the case ith element is -1, jth element is -1, and kth element is 2. And if you find their sum, it is equal to 0, right? So this is our one of the possible case, right? And there might be another case also, like in this case, if ith element is pointing to -1 and jth element is pointing to 0 and kth element is pointing to 1. So in this case, sum is also equal to 0. So we will return the two triplet for uh, this test case, right? So yeah, this is a simple one. We can use three loops, right? We can use three loops and check if nums I plus nums j plus nums k is equal to 0 or not. If it is equal to 0, then return triplet, right? But the important thing is not this one. Important things is how to handle the duplicates, right? And also without using the set, because if you use the set, then there is no need to take extra case, because we know that set is a data structure which include all the element without duplicate, because duplicate element is not allowed into the set. When we push into the set any element, then duplicate element is always removed, right? But here the case is we can solve this problem without set also, right? So how can we solve this problem? So actually there are three cases possible, right? So in this first case, what is happening here, like in this first case, suppose that, let's suppose the three case. This is the first case. So in this first case, let's suppose ith element and ith plus 1 element is equal, right? So let's suppose we make some triplet like -1, 2 and 1, because this is one of my answer. But if we consider this is the ith element, this is the jth, and this is the kth element, then we also include another triplet. But this one and this one is same, because of the ith element and ith plus 1th element is both are equal, right? So if both are equal, so we have to skip the step, right? So in this case, this belongs to first case, right? So in this first case, if ith element is equal to ith minus 1, right? So we will continue, means skip the step. And if you skip the step, then we don't include the duplicate element, right? And similar case for the second case also. This is the belong to second case, and in this second case, jth element and jth plus 1 element is both are equal, here 2 and 2. So in this case, what can I do? We can also continue, and the condition is this one, right? If jth element is equal to jth minus 1, like let's suppose this is jth and this is jth minus 1. So if both are equal, then we will continue. And similar for the last case, if kth, let's suppose this is kth element and this is kth minus 1, so both are equal, 2 and 2, so we will keep this a step also. So if we talk about the time complexity, so time complexity is equal to big of nq, and space complexity is big of 1. Time complexity is big of nq because of we use here 3 loops, right? And space complexity is big of 1 because we don't use any extra space, like don't use next, right? So let's see the code for this solution, and after that we will move to the another optimization, right? So this is the first code, method 1 code. So in this case, our step is simple, like in this the first step is sort the array, right? And after that we can take 3 loops, this one, this one, and handling the duplicate. After the every loop we will take care of handling the duplicates, right? If ith minus 1 element is equal to ith element, then we will continue, and similar for both all three cases. And the like base case is when if the sum of ith element and kth element and kth element is equal to 0, so we will push that particular element into the vector, and again we will send and put the temporary vector into the resultant vector, and after that we will return the resultant vector, right? So let's move to the another optimization because it's take big of NQ. So can we optimize this approach? Yeah, we can optimize this approach. So let's discuss how can we optimize this approach. So the first step is sort the array, right? And second, we have to find the triplet, right, whose sum is equal to 0. So the approach is like we fix the ith element, right, and we check for the jth and kth element whose sum is equal to 0, like whose ith element plus jth element plus kth element is equal to 0. So let's take a case. So in this case I will take example -4 minus 1 -1 0 1 and 2. Okay, so let's suppose this is the ith element and this is the jth element and this is the, because in this case we fix jth element is ith plus 1 and kth element is n minus 1, right? 0 1 2 3 4 5. So in this case, if we add the sum of all the ith plus jth plus kth element, then sum is what? -1 plus -1 plus 2. This is equal to -1. These are not equal to 0. And also in this case, it is less than equal to 0. So if we fix the ith element and we have search space is what? This one. This is our search space. So we know that the current sum is less than 0. So what can I do? We have to increment the jth element, right, from here to here, because this is the increasing order, right? And if we increment the jth element, then ultimately our current sum is increase, right? Then again we find the sum, then current sum is -4 plus -1 plus 2. This is equal to sorry, here is not +1, here is -1. Okay, so current sum is also uh, -3. Yeah, -3, which is less than 0. Okay, so in this case again our sum is -3, which is less than 0. Then again we increment the jth element, so j is pointing to 0. So in this case, then again we find the current sum -4 plus 0 plus 2, and which is equal to what? -2. This is less than equal to 0. Then again increment the jth element, and here the jth pointer is pointing to 1. So current sum is what? -4 1 plus 2, which is equal to -1, and which is also less than 0. Then again increment the jth pointer, but in this case j is equal to k. So this is our base case. So in this always j is less than k, so we are out of the loop, right? And in this case what can I do? We can increment the ith value, right? Like if we increment the ith value, like from things from here, so initial I is pointing to here, but current now ith pointer is pointing to -1, and j is pointing to this one, and k is pointing to 2. So if you find the current sum, like -1 plus -1 plus 2, this is equal to 0, and if we find the triplet sum is equal to 0, then yeah, this is our one of the possible case, and we will return into the answer. And then again if we find the current sum which is equal to 0, then increment the jth pointer and decrement the kth pointer. because of maybe, yeah, this is one of the case, but maybe in this between we have also get another uh, and another triplet. So in this case we will increment the jth element and decrement the kth pointer, right? So if we increment the jth, and j is pointing to here and k is pointing to right, so again if you find the sum, then sum is equal to what, -1. So I just remove for the better clearation. So here k is pointing to 1, so current sum is what, -1, 0 and 1. So this is also equal to 0. So it is also another possible test case, -1, 0 and 1, right? So this is how we can solve this problem, right? So actually there are three cases possible. So in this first case, sum of all ith plus kth, jth plus kth element is equal to 0, then we have to return the uh, current ith element and jth element and kth element, and also we increment the jth pointer and uh, decrement the kth pointer, because maybe we get some another triplets. And in this case if sum is less than 0, then in this case we increment the jth pointer, because array is increasing order, because in the starting we sort the array, right? So array is increasing order, and if you increment the jth element from here to here, then might be some maybe increment, current sum is increment, so in this case we might reach out the 0, right? And else case, if current sum is greater than 0, okay, so maybe in this case what can I do, like we can decrement the kth pointer, because from the left to right, if array is increasing order, so right to left what, right to left array is decreasing order, so that's why we decrement the kth pointer. And if I talk about the time complexity, so time complexity of this solution is big of n square, and a space complexity is big of 1. So let's discuss the code. Okay. So code is here. So it is also some simple code, like in the first step we sort the array and take one for loop for the ith pointer, and we set low and high. Low is means jth element, and high is kth element, right? There is there is just a change of the variable name, nothing else. And in this case we also take care of duplicate, because this is also similar to the above case, like handling the duplicacy is similar to the above method, right? So it is, I have already discussed the how can we solve the how can we solve the duplicate. Okay, so this is the case. Okay, so in this case what can I do, so we can take a two pointer, so low is pointing to ith plus 1 and high is pointing to n minus 1, and again we take a loop. This is our base case, low is always less than high, right? And this is the first case, if the ith plus lowth and highest element sum is equal to 0, then we all put into the vector, right? And then return and push into the resultant vector, right? And after this step we increment the lowth low plus plus and decrement the high minus minus. And this is also one of the important base case, right? So if we have a array like look like this, uh, -1 -1 0 1 1, here is also 0. Let's suppose this is the ith element, and this is low and this is high, right? So in this case, what can I do? Like we have uh, this pointer is pointing to -1 plus 0 and plus 1, and which is equal to 0. So this is our possible case. But the things is what, like in this case, if you increment the ith element from here, let's suppose here we increment the low from here to here, and let's suppose this is initial high and current high is, so current value is what, -1, 0 and 0, and which is also equal to 0. So here we include duplicate also. So handling the duplicate, what can you do? We take care of condition, right? So in this case, what can you do? Let's suppose this is a low, initial low, and this is high, right? So we decrement the low, decrement the high, and increment the low until we get some equal number, like 0 is equal to 0, then increment the low from here to here, and 1 is equal to 1 here. So decrement the high from here to here, right? So in this case, we have to avoid the solution, like avoid the duplicate, right? So this is one of the case how that's why how we can solve the handling the duplicates. And another case we have, like sum is current sum is equal to less than 0, then in this case we increment the low and otherwise decrement the high, and after that we will return a resultant, and you take big of n square, a time complexity, and a space complexity is still big of 1. So thanks for the watching.